For the coffee question, A, the initial amount, would be 130 milligrams. The rate at which coffee is eliminated is 11%. For math formulas, we'll use decimals, which would be 0.11. For the time, question is how long it will take. That will actually be our variable. We can use x or t. Y will be the final amount. We want half the caffeine to be eliminated. So if our initial amount is 130, half of 130 would be 65. Plugging the numbers into the formula, y equals a parentheses 1 minus r to the t power. Y would be 65. The initial amount would be 130. The rate would be 0.11. And the time is what we're solving for, which we'll use the variable x. To solve this, we can first divide by 130 on both sides. 65 over 130 would reduce to 1/2. 1 minus 0.11 would be 0.89 to the x power. Again, when we have variables as an exponent, that's when we can use logarithms to solve it. Next step, I'll switch around the equation. I'll put 0.89x on the left side and 1/2 on the right side. This way it's in the standard form that we've been solving the previous questions. Again, to solve exponential equations, we can switch into log equations. 0.89 would be the base, and x and 1/2 would switch sides. So we'd have log 1/2 base 0.89 equals x. All answers in log, again, should be in standard form or base 10. So using our change of base, this would be log 1/2 divided by log 0.89 equals x. If you wanted to, you could change this to 0.5, or we could change this decimal to 89 over 100, but it's okay to have fractions inside of logs. If you use a calculator, the answer would be 5.9480, which, looking back at the question, how long will it take for half the caffeine to be eliminated? In terms of hours, it'd be about 6 hours to eliminate half the caffeine. The half-life of carbon-14 is 5,760 years. What is the value of K? By definition, half-life is a substance, which in this case 5,760 years, half of that substance disappears. In terms of exponential decay or growth, this would be decay because half-life, your life is decreasing after 5,760 years. So the equation for decay we'll be using y equals a times e to the negative kt power. For variables, a, the initial amount. The problem does not state the initial amount, but since we're using half-life, we can pick any number that we want. Nice easy number that we can take half of would be 2. K is the constant. That's what we're going to be solving for. T is the time. Time for the half-life in this case is 5,760 years. And y is the final amount. If we started with 2, half-life, again, half of it disappears after 5,760 years, so half of 2 would be 1. Plugging these three numbers in, we can solve for k. Y is equal to 1, a is equal to 2, E again is a constant from natural logs. We have negative k times t. T is 5,760. And k again is what we'll be solving for the constant. First step, you can divide by 2. And we'll have 1/2 equals e to the negative 5,760k. Same steps as before. I'll rewrite this equation with e on the left hand side. 5,760k equals 1/2. And again, with a variable in the exponent, we can use logs. In this case, whenever we have e, we want to use natural log, ln. The ln again would be the base, e. We can leave that off or write it there. And just like before, the other two numbers would switch sides. This would become the natural log of 1/2 equals negative 5,760k. To solve for k, we can divide. And our final answer, natural log of 1/2 divided by negative 5,760 is what k is equal to. Using a calculator, you can get a decimal for this. That decimal would be 0.00012. K again is just a constant. That constant would be the same for any problem dealing with the specific carbon-14 and half-life. For this question, we're given the equation y equals 1.31 e to 0.0038 t. And we want to find out the population in 2009. T is the time after 2005, so 2009 would be 4 years later, so t would be equal to 4. Multiplying 0.0038 times 4, that would be 0.0152, and we'd still have, the t would be gone because we're plugging a 4 in. This would be your final answer without a calculator. If you had a calculator, you can use the E button to find out this decimal, multiply by 1.31, and that actually comes out to 1.33. In this problem, China started with 1.31 billion people in 2005. 4 years later, in 2009, they had 1.33 billion people. To figure out if events are independent or dependent, you'll see if the events are related. The first question, the outcomes of 2 coin flips. When you flip a coin once, it does not affect the second coin flip. So in this case, the events would be independent. In the second example, sending 2 students to the library. If you have a class full of students and you pick a single student, that reduces how many students you have in class, which will change the percentage or chance of selecting the second student. In this case, the 2 events would be dependent. For this example, Tim has 3 choices on the books that he wants to buy. So he has 3 different ways that he can choose a book. Each book is also available on print or CD, so he has 2 choices. So we'll multiply by 2, 3 total books to choose from, 2 ways to choose those books, which would be 6 total choices. For this question, we'll be making 2 choices. We're going to make a choice on which drink we're going to have, and we're also going to have a choice on which salad we have. Counting up the drinks, we have water, coffee, juice, and milk. So we have 4 different choices for the drinks. For the salad, we have pasta, fruit, or potato. So we have 3 different choices for potato. Again, multiplying those gives us 12 different options to order a drink and salad. For this first problem, we'll have 5 numbers. It'll be 1, 1, 2, 3, and 4. And for each of these, we'll find the mean, the median, and the mode. Again, the mean is the average. To find an average, you'd add up all the numbers. 1 plus 1 plus 2 plus 3 plus 4. And that would equal 11. And you divide by how many numbers you have. In this case, there's 5 numbers. Our mean would be 11 over 5, which you can leave as a fraction. Or if you get a decimal, that decimal would be 2.2. The median would be the middle number. Basically, you'll start crossing off numbers from left to right until you get to the middle number, which would be 2. The mode would be the number that repeats the most. We had the number 1, which repeated twice, so our mode would be 1. Second question we'll do. Numbers will be 9, 5, 9, 5, 8, and 6. And again, we'll find the mean, the median, and the mode of these numbers. Best thing to do when you have numbers is to put them in order first. That way when we get to the median, we can find the middle number when it's in order. For example, I'll put the 2 5s first, then the 6 and the 8, and we have 2 9s at the end. These numbers only have to be in order for the median, but it's best to put them at the order at the beginning so you don't forget when you get to the median. For the mean again, we'll find the average, add up all 5 numbers, 5 plus 5 plus 6 plus 8 plus 2 9s, and that would add to 42. Again, divide by how many numbers you have. In this case we have 7. 42 divided by 7 would be 6. The median again, what you want to do is cross off one number on the left and one number at the right on each time. In this case we're left with 2 middle numbers, 6 and 8. When you have 2 numbers in the middle, your median is actually the number halfway between 6 and 8. In this case would be 7. So our median would be 7. The mode again is the number that repeats the most times. We have 2 5s and 2 9s. If they repeat the same number of times, you can have 2 modes, 5 and 9. For the first problem, we'll decide whether it's a permutation or a combination. The first question, we have first, second, and third place in a race of 5 people. In this case, the order would matter. First place would be different than second place, which is different than third place. If order matters, that would be a permutation. For the second question, choosing 2 toppings to go on a pizza. In this case, the order does not matter for toppings. If we choose pepperoni then sausage, it's the same thing as choosing sausage then pepperoni. In this case, it would be a combination because the order does not matter. Our first problem for the section is permutation 8, 2. Again, 8 would be equal to n and 2 would be equal to r. Plugging them into the equation, we would have 8 factorial divided by n minus r, which is 8 minus 2 factorial. 8 factorial would stay the same. 8 minus 2 would be 6 factorial. Factorials again are that number times itself, everything down to 1. So in this case, 8 factorial would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. One way to solve this would be to multiply all the numbers and then divide. A nice easy shortcut is if we have 6 times 1 on the bottom, 6 all the way down to 1 on top, each of these would cross cancel and we'd be left with 8 times 7, which would be 56. So permutation 8, 2 is equal to 56. First problem we'll solve is combination 8, 4. Again, 8 would be what n is, and 4 is what r is equal to. In this case, we'll have 8 factorial. n minus r would be 8 minus 4, which would be 4 factorial. And we also have r factorial, which is 4, so we have another 4 factorial in the denominator. Writing this out, 8 factorial would be 8 times 7 times 6 all the way down to 1. 4 factorial would be 4, 3, 2, 1. And another 4 factorial would be 4, 3, 2, 1 again. Again, one shortcut on this, the 4, 3, 2, 1 in the denominator and numerator, you can cancel out. From here again, we could multiply straight across and divide out to get our answer. One other shortcut is we can cross cancel or simplify. 8 divided by 4 would be 2. And the 2 we can cancel. 6 divided by 3 would be 2. And we're just left with a 1 in the denominator, which we can ignore. So we'd have 7 times 2 times 5, which would be 70. Last question for the section is selecting 2 of 8 employees to attend a business seminar. This will be a combination again, because the order we select the employee does not matter. As long as it's the same 2 employees, switching their order, they'd both be going to the seminar. So in this case, it would be a combination. Our total is 8 employees, and we're selecting 2 employees. So combination 8, 2. In this case it would be 8 factorial in the numerator. 8 minus 2 would be 6 factorial in the denominator. And combinations have the extra factorial of 2 factorial. 8 factorial again would be 8 times 7 times 6 all the way down to 1. 6 factorial would be 6 times 5 times 4 down to 1, and 2 times 1. Again, simplifying this, 6 times 5 times 4 times 3 times 2 times 1, we can cancel those. And if we want to simplify even further, 8 divided by 2 would be 4. The 1 again in our denominator we can cancel out or ignore, and we're left with 4 times 7, which is 28. So in this case, if we have 8 employees and we want to select 2 of them, there's 28 different ways to select those 2 employees. For probability, we'll have a fraction for our answer. It'll be the chance of success, how many successes there are, divided by how many possible outcomes. First problem, we'll have probability of rolling a 5 on a 6-sided die. Success would be a 5. There's a single 5 on a 6-sided die, so there's one chance of success. And the number of outcomes, or how many numbers are possible on a 6-sided die, there would be 6 sides. So you have a 1 out of 6 chance of rolling a 5. Second question, and last question for the section, the probability of tails on a coin flip. On a coin there is 1 tails, one side has tails, and a coin has 2 sides, so the probability of tails would be 1/2 or 1/2. For this problem, we'll be using combinations. When Bob reaches into the box and picks out 3 football cards, or 3 cards that he wants to be football, we're doing multiple events. Combinations will be for multiple events, which the order does not matter. It does not matter which football card he pulls out first, just as long as he pulls out 3 football cards. Probability again will be a fraction. If we do the numerator, the chance of success, we'll have a combination for the football cards. The first number is the total number of football cards, which would be 8. And the second number is how many we're selecting, or how many we want. In this case it would be 3. So combination 8, 3 tells you how many successes, or how many different ways there are to pull out 3 football cards. For the denominator, we'll have another combination. This combination will be the total number of outcomes, again for all the cards. If you count up all the cards, there's 12 baseball, 8 football, and 5 basketball. Adding those together, there's 25 total cards. We want 3 football cards, so we're going to be picking out 3 cards. So we're going to find out the combination 25, 3, how many total ways there are to pick out 3 cards from this box of sports cards. Solving this, we have combination 8, 3. That would be 8 factorial divided by 8 minus 3 would be 5 factorial. And also the combination has the 3 factorial on the denominator. Our second fraction will be for our second denominator will be 25 comma 3 for the total combinations, and that would be 25 factorial divided by 25 minus 3 would be 22 factorial, and the extra 3 factorial goes on the end. Simplifying this out, 8 factorial would be 8 times 7 times 6 all the way down to 1. 5 factorial would be 5 down to 1. And 3 factorial would be 3 down to 1. For the bottom fraction, we'll have 25 multiplied down to 1. What I'll do in this case is I'll go down to 22 and I'll put dot 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 times to 1. That's because we'll be crossing these numbers off in just a minute. For the denominator, we'll have 22 factorial. And again, I'll do 22, 21, and I'll put dot 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 times to 1. So we'll have all the numbers from 21 to 1 in there. And again, we'll cross those off in just a minute. 3 factorial would be 3, 2, and 1. Simplifying this, we have 5 through 1 we can cross off for the numerator of this fraction. 3 times 2 would be 6, so we can actually cross off the 3, the 2, and the 6. And the 1 again we can ignore, so we're left with 8 times 7 for the top, which would be 56 for a numerator. For the denominator part of the fraction, we have 22 to 1 on the top of the fraction and 22 to 1 on the denominator of that fraction, so those will cancel. We have 3 times 2, which would be 6, so if we divide by 6, this 24, we can divide by 6 and we'll be left with a 4. So we'll have 25 times 4 times 23. If you multiply those out, that comes out to 2300, which is how many possible ways you can pick out 3 cards from this box. Our final answer, we can reduce this fraction. Dividing by 4 would give us 14 over 575. So for this question, Bob wants 3 football cards. He has a 14 out of 575 chance to get 3 football cards if he randomly picks out 3 cards. Next question we'll do for that same problem with the box of sport cards will be the probability of picking 1 basketball card and 2 football cards. Again, if we're doing multiple events and the order does not matter, it doesn't matter if we pick basketball and football or football then basketball, we'll be doing combinations. If we do basketball first, it'll be combination. The first number is the total number of basketball cards. Looking back at the word problem, that would be 5. And we want to choose one of those. The second event we'll multiply by to find out the total number of ways to get basketball and football would be combination. The football cards, there are 8 total, and we want to pick out 2 of those. So for the number of successes for 1 basketball and 2 football cards, we can find the 2 combinations and multiply those together. For the denominator, we'll have combination. There's 25 cards total in the box, and we're picking out 3 total cards. One shortcut we can use, that previous question we actually solved, combination 25 comma 3, and that was equal to 2300. Solving combination 5 comma 1,